So yeah, to recap from the last unit, I just want to write this on your notes too, along with it being up on the board. If you multiply two powers that have the same base, you're going to add the exponents. Right? It's the product property. Also, if you see a variable with no exponent, that's assumed to be a 1. So, like on this first one, we're just multiplying all these terms. We're multiplying monomials here, just single-termed polynomials. So we're just going to multiply everything. So like 3 times 9 is 27. M times m squared. Mason, you pretty much just answered this question. What's m times m squared? M cubed, yeah. And then n squared times n is also n cubed.
But you can't add those together because they're different.
Right. When the bases are different, you just leave them. You can't combine them. Right. So that's it for that one. Number 2, what's 6 times 3? 18. And then y cubed times y to the 5th is going to be y to what power?
8.
Y to the 8th. Yeah, good. Okay, so that's just kind of a little review of that exponent property. That's going to come into play. We're going to use that over and over and over and over again, even within a single problem. So I just wanted to reiterate that. Now, anytime we're going to multiply these polynomials, really what we're going to be doing is utilizing the distributive property. This is going to be more obvious. Distributive. This is going to be more obvious when what we're multiplying is a single term to a polynomial. It'll be a little less obvious when we're multiplying binomials or trinomials, but essentially that's what you're doing. So, like in number 3, we've got a constant monomial times a quadratic trinomial. Right? A constant monomial times a quadratic trinomial. I'm just going to keep using those words so you don't forget what any of that means. But basically all we need to do here is just distribute the 4. Do exactly what you might think we do. So we're going to distribute the 4, and that means I'm going to multiply each of these terms by 4. Now, even though the multiplication is like pretty simple for the most part here, definitely have a calculator by your side to just double check as you're going. So 4 times 3x squared is going to be 12x squared. 4 times 4x is 16x. And 4 times negative 8, negative 32. Yeah. You'll also notice that as I work these out, I'm going to be consistently using this. I've heard it called like a rainbow notation for the distributive property, where it kind of looks like you're drawing a rainbow. But basically what I'm showing is that I'm multiplying this term by every single term in the next polynomial. Any questions about number 3? So number 4 is very similar. We're going to distribute, but we're distributing like this whole term. Okay, so we just want to be careful as we multiply. Oh, looks like there's only 2 terms of that next one. So let's erase that. Wow, that's the ugliest whiteout job I think I've ever done. Okay. So let's multiply the first 2 terms. You got 1/2 x squared y times 6xy. Okay, well, what's 1/2 times 6? 3. Okay, good. And then x squared times x, x cubed. And then y times y. So it's like y to the first times y to the first, y squared. Right? Okay, so that's the first term. And then the second term, we get 1/2 times 8 is 4. X squared times x squared is x to the 4th. Y times y squared is y cubed. So we're just multiplying everything there. Number 5, we're multiplying a binomial by a binomial. Okay, so notice 2 terms, 2 terms. So we're just going to extend how we think about the distributive property. We're still going to use the distributive property, But instead of just distributing a single term, like we did on all the other problems we've done so far, we're going to distribute an entire polynomial. So in other words, we're going to take this g plus 2 and distribute it to both g and 4. Now, the way that works out is we've got g times g plus 2 plus 4 times g plus 2. Notice we're multiplying this g plus 2 by both of these terms. So once you get that first distribution set up, you can see that we're going to have to distribute again. So we're going to distribute this g and this 4 to get g squared plus 2g plus 4g plus 8. The last step is going to be to combine any like terms you might have. So do I have any like terms? Yeah, I've got the 2g and the 4g. So what's 2g plus 4g? 6g. So I get g squared plus 6g plus 8. And so my result here, which will be a pretty common result, is a quadratic trinomial. It's quadratic because the degree is 2, trinomial because there are 3 terms. Let's try number 6. We're going to distribute b minus 3 to both of these. Okay? So we're multiplying b minus 3 times b and b minus 3 times 2. So I'm going to set this up as b times b minus 3 plus 2 times b minus 3. In other words, what's really going on here, y'all, is we are multiplying every term in the first polynomial to every term in the second polynomial. Here we get b squared minus 3b plus 2b minus 6. I can combine my like terms, and I get b squared minus b minus 6. Unfortunately, my b's kind of look like 6's here, so make sure you're writing the right thing down there. Yeah. b squared minus b minus 6. Again, this is a quadratic trinomial. That's going to be your most common type of polynomial that we will get. Now, number 7 looks different, but it's really kind of the same thing. When I say a plus 1 squared, I want to caution you, this does not equal a squared plus 1 squared. You do not, under any circumstances, distribute that exponent. That's not how the exponent works. Instead, what you're going to do is you're going to rewrite this as a multiplication problem. If I say a plus 1 squared, what that means is a plus 1 times a plus 1. So it's a plus 1 times itself. Once you rewrite it like that, it becomes a little bit more obvious what to do. We're going to distribute the a plus 1 just like we did in the previous 2 problems. So take this a plus 1, multiply by a, and multiply by 1. So I have a times a plus 1 plus 1 times a plus 1. And then I got to do the distributive property again. So I've got a squared plus a plus 1a is just another a plus 1 times 1 is 1. So what's my final answer going to be? This term, a squared, can't be combined with anything. So it's just a squared plus, what's a plus a? 2a plus 1. One times, when we distribute, we're multiplying, not adding. So shocker here, we get another quadratic. Oh, I misspelled quadratic on the last one. Oops. It's not a quadratic. All right, any questions on any of those three problems? All right, so that's one way to think about how to multiply. I'm going to show you two different ways, or a total of three, but two different than this. So this is just one technique you can use, and I want to sort of preface this with, at the end of today, I don't care which way you learn how to do this. So I'm just going to show you three different ways you can think about multiplication, one of which is thinking about it as a generalized form of using the distributive property. I mean, that is, like, when you really break it down, this is sort of the most, like, the purest algebraic way to approach it. Okay, but there are a couple of different other techniques we can use, like we can think about multiplication as finding the area of a rectangle. So, like, what is the formula for finding the area of a rectangle? You have a rectangle. Say it's a 2 by 3 rectangle. What's the area?
Oh, it's length times width.
It's length times width, right? So 2 times 3 would be 6, right? So yeah, so it's just length times width. In other words, to find the area of a rectangle, you just multiply the two dimensions together, right? Well, in these binomials, I'm just multiplying two things together. So one way how I can sort of interpret this is, okay, well, if I think about this as like length times width, then I can set this up using a rectangle or like a box and multiply the terms individually. So let me kind of show you what I mean. Now, it doesn't matter which one goes on top and which one goes down, but let's say that this side, like the length, is q plus 3. And then the other dimension is q plus 7. This is supposed to be a q, even though it looks like a 9 or an a or something. Now, if I set it up like this, then what I'm going to do is multiply each column by each row. And then my result will be the sum of all the terms inside the box here. Sometimes people call this the box method for multiplication. Exactly. Like if you are in biology or you've taken biology, you may have worked with Punnett squares before. This is almost exactly the same idea. Okay? So what's q times q? Q squared. 3 times q is 3q. 7 times q is 7q. And what's 3 times 7? 21. So the only thing that you have to do after that is add up the like terms, which, if you set it up correctly, will always be on the diagonal. Notice we get 7q plus 3q. What is 7q plus 3q? 10q, right? So we've got our answer here is q squared plus 10q plus 21. A lot of people, I would say, like, not everyone, but most people will find this to be like their preferred method. It's very visual. You organize your work in a nice, clean way. There's less stuff to write. And I don't know, I think it's just a little easier than the last one. But it's really up to you which way you want to go. Again, we have a quadratic trinomial. Number 10. We're going to work this out the same way. So I'm going to put 2w minus 5 right here. Yeah, w minus 3. Now I just do all my multiplication. I'm going to multiply every row by every column. All right, so now we're going to multiply. We got 2w times w is 2w squared. Negative 5 times w, negative 5w. 2w times negative 3 negative 6w. Negative 5 times negative 3, 15. The only thing left to do is to write my answer and combine my like terms. So I have 2w squared minus 11w plus 15. Okay, again, shocker here, we have a quadratic trinomial. All right, let's take a look at number 11. Notice the second binomial is not in standard form. That's okay. That doesn't really affect how we're going to work this out. The only thing that will affect is like our like terms. We might have to hunt them down. They won't be along the diagonal in this case. So 6h minus 2 minus 3 minus 2h. So now I'm going to multiply everything out. Negative 3 times 6h would be negative 18h. Negative 2 times negative 3 is plus 6. 6h times negative 2h is negative 12h squared. And negative 2 times negative 2h would be positive 4h. So the terms are sort of arranged in a weird order here, but you can still see your like terms are going to be right here. So you want to look out for that. Yes, ma'am. So this is going to be negative 12h squared minus 14h plus 6. So the minus 14 is coming from negative 18 plus 4. We get a quadratic trinomial here. All right, let's do one more using this method. Okay. So here we've got negative 3 plus 4j, and then 3j plus 4. So what I want you to do is try to fill this out yourself. Challenge yourself and see if you can get the right answer here. We've done 3 examples using this technique. So I'm going to give you like a minute to see if you can come up with the answer. All right, let's see how you did. Got a negative 9j here. Negative 9j. Off to the right start here. We're good? Okay, then what'd you get in this box? 12j squared. Good. And then this box? Negative 12. And then this box? 16. All right, great. Okay, so you're getting the hang of it. Now let's see. Now comes the real test, though, is to see if you can actually get the complete right answer here. 12j squared. Here are my like terms. Plus 7j. That's probably, if you made a mistake, that's probably where it's going to be. Use your calculator if you're having trouble adding negatives. Minus 12. That's your answer. All right, raise your hand if you got it right. Okay, all right. Okay, good. So that's the second method, okay? Again, I'll reiterate, once you know all the methods, whichever one you want to pick is fine. Like if you're kind of like you understand this and you feel pretty good about this method, then use this every time. I mean, you don't have to. All right, so let's look at one more method. This is a quadratic trinomial, by the way. So this is called the FOIL method. Okay, so FOIL here is an acronym that stands for first, outside, inside, last. You did this in biology too. Perfect. So this is, hopefully this is crossing over. Basically, this is just another way to kind of keep track and organize all of your multiplication. Because ultimately what you're doing here, like in the previous two methods, is you are going to multiply each term in the first polynomial by each term in the last polynomial. So with this FOIL method, you approach, it's sort of like the distributive method, except instead of distributing the entire first polynomial to the entire second polynomial, we're actually going to distribute the individual terms. So like, if I'm going to do, the first term would be like x times x here, which would be x squared. The outside terms would be x times 2, 2x. The inner terms, 1 times x, would be x. And the last terms, 1 times 2, would be 2. So your final answer would be x squared plus, what's 2x plus x? 3x, and then plus 2. So this is very similar to the distributive method, and in fact, you really are using the distributive property here, but this acronym of FOIL can kind of help you remember like what you're supposed to multiply. Okay? So let's take a look at 13 and we'll try this little FOIL method. So FOIL stands for first, outer, inner, last. So let's do first. X times x is what? X squared. Then outer, x times negative 3. Negative 3x. Notice in this sort of organization, I'm starting by I'm distributing the first term only. Then I go and distribute the last term. So the inner, 3 times x is 3x. And then the last would be like 3 times negative 3 is negative 9. So you still have to combine. Notice on all three of these methods, you're still having that last step of combining your like terms. This is no different. So we get x squared. What's negative 3x plus 3x? 0. Yeah, so those two terms sort of cancel each other out. Minus 9. All right, number 14. Oh, well, we didn't name this one. This one, actually, is the first one that's a little different. It's still quadratic, but this one is not a trinomial. It's a binomial. Okay, number 14. First, outside, inside, last. FOIL. First, outside, inside, last. Okay, so basically we're just keeping track of multiplying each term in the first polynomial to each term in the second polynomial. Z times z is z squared. Z times 2 is 2z. Now we distribute the 3 inside last. So 3z plus 6. Combine our middle two terms here, and so we get z squared plus 5z plus 6. And we're back in this quadratic trinomial streak. All right, number 15. Now when I see h minus 2 squared, what do I really need to do here? How do I rewrite this? Yeah, good. H minus 2 times h minus 2. So rewriting it like that can help to sort of remind you how to do it. So now I'm going to do my FOIL method. First, outside, inside, last. Combine my two like terms and get h squared minus 4h plus 4. All right, so one more. We got 3x plus 1 times 3x minus 1. So first, what's 3x times 3x? 9x what? Squared. Outside will be minus 3x. Inside, plus 3x. And finally, last, will be minus 1. What's going to happen to these two middle terms? Yeah, they cancel each other out, right? 3x minus 3x is 0. So I got 9x squared plus 0, I don't need to write that, minus 1. So we get another quadratic binomial. So let's practice these last few problems. Wait a minute, look at this. Uh-oh. How is this problem different than all the problems we've done so far? This one has 3 terms. Oh boy. Yeah, how do we do this? All right, so yeah, so depending on which method you use, you can use any of the methods to do this. So what I would like to do is for 17 and 18 is to show you how you would work this out if you have a trinomial instead of a binomial using 2 different methods. Like just kind of depending on which method you like. You can extend any of them. Like you can apply all of them to these. But I want to go with what you guys feel like you're going to use more often. So y'all said first that, at least what I heard, was that you guys like the box method. So I want to show you first how you would apply the box method to this, and then I'll show you how to do the distributive property with it too. So first let's set it up for the box. The only difference here is that instead of having like a 2x2 box, you're going to have a 2x3 box. Okay, so like I'm going to have my x minus 2. But then down the side, I'm going to have x squared plus x plus 1. And then basically have a 2x3 box instead of a 2x2. And then once you get it set up, you basically do the same thing that you did before, which is you just multiply all the rows by all the columns. X times x squared is x cubed. Negative 2 times x squared is negative 2x squared. X times x is x squared. Negative 2 times x is negative 2x. X times 1 is x. And negative 2 times 1 is negative 2. Oh, that's a minus 1. Uh-oh. Yeah, so if this is minus 1, let's fix it. This would be a minus x, and this would actually be a positive 2. Thanks for catching that. So another thing to keep in mind when you're doing these, multiplying these trinomials, is you're probably going to have more than one group of like terms because you have so many more terms. So like instead of just combining the linear terms here, we have to also combine the quadratic terms. Now they should, as long as everything's written in standard form, you'll still find the like terms along the diagonal like that. So this shouldn't be too hard to find. So my final answer here is going to be x cubed, x squared minus 2x squared is going to be minus x squared minus 3x plus 2. And this result is a cubic polynomial with 4 terms. Number 18, you could use box method again for sure. I just want to give you options here. So with number 18, I'm going to go the distributive route. Okay, and what I'm going to do is I'm going to distribute first the d to all 3 of these. Right, so that would be d cubed minus 4d squared plus d. So that's just distributing the first term. Then I need to distribute the plus 3. So I've got plus 3d squared. Move this over so you guys can see it. 3d squared minus 12d plus 3. Once again, you've got those two groups of like terms. You've got your quadratics here, and you've got your linears. So I'm going to group those together. My final answer here is going to be d cubed minus d squared minus 11d plus 3. Just like the last one, this is a cubic polynomial with 4 terms. Now, you can use these techniques to actually find area of a rectangle. I know we talked about like using that as like a kind of a way to think about it, but if I'm going to ask you to find the area of a rectangle and both dimensions are given in terms of x, then you're going to sort of set it up like one of these box method problems. Okay? To find the area of a rectangle, the formula is length times the width, or base times height. However you want to name the two dimensions, it's just the two dimensions multiplied against each other. So like for number 19, if I have 2x plus 3 times 4x, so I have 4x times 2x plus 3, I can use either the box method. This one would actually just have like, it's going to be 1 by 2. Like if I have 2x and 3. So that'd be 8x and 12x. Wait a minute. 8x squared and 12x. Or you could just use the distributive property here and distribute and get the same thing. 8x squared plus 12x. So either way is fine. For number 20, we've got sort of like a, well, we have a square here. X minus 5 times x minus 5. So like if I'm setting this up using the box method, right, I'm going to have x minus 5 and x minus 5. And I get x squared minus 5x plus 25, which would be x squared minus 10x plus 25.